Hello, today we're going to be dealing with power functions and proportionality. So as we look at this, a power function, we have the formula y equals some constant times x with a known power of k. When we think of directly proportional examples, we think of the formula y equals k times x. So we can see that these formulas are extremely similar. The k, however, is used differently. So here the k is a constant. And in the power example, the c is that same constant. And in the power functions, this place that we use k is a known exponent. So let's take a look at our example. It says the length of a skid mark, and this is our symbol for proportional, so is proportional to the square of the speed. So I have length of the skid mark as my first thing, speed as my second, and I want to assign variables to them, so we'll use L and we will use S. The order matters. Whatever comes first is what we want to put into Y, so we'll have length of skid mark is some constant C times, and I often use parentheses, but you can use a dot too, the speed, and here's our exponent, squared. So yes, it's a proportional relationship, but it's not directly proportional to speed, rather it's a power of speed, which makes it a power function. So we're ready to move on to our second sentence. It says, given that at 30 miles per hour, skid marks would be 40 feet long. So based on the labeling here, 30 miles per hour, that's a speed, and 40 feet long, that's a length. So I actually have an ordered pair. And this ordered pair can be plugged into my formula in order to find this constant. So length of skid mark is 40 feet, is some constant times 30 squared. So I have a little bit of math and algebra to do. So 40 is equal to C times 900. Divide by 900 on both sides. And I get C, the constant is, and I rounded my decimal to 3 decimal places, so 0.044. And you can follow directions on the problem that you're working with. So now I want to take this and plug it into my formula to have an actual model for the scenario. So the length of a skid mark is 0.044 times the speed squared. So this is my power function that represents this scenario. So finally I get to move to the question, and the question is how fast, I think we have an extra word there, would a car be going that left 160-foot skid marks? So this 160 I recognize as a length, and so I'll put that into my formula for L and fill in the rest of my formula, and it looks like I'm solving for speed. And so in order to do that, I will first divide on both sides. These cancel, so speed squared is equal to, and I got 36.36 repeating on my calculator. Then I have a squared, so the opposite or inverse of squared is square root, so I'll do square root on both sides. Squared and square root cancel, so I have S is equal to, I type in my calculator square root of this number, and round it off, that gives me 60.3 miles per hour. So to retrace our steps, power functions are examples of proportionality. The only difference between them is that in a power function we have an exponent. When we read this relationship, it was proportional with an exponent, so it is a power function. We used the first set of numbers as an ordered pair to figure out the constant of proportionality, the C, in the power function formula. Then we used our formula to solve an example.